We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 6/10% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can't physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they are made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has two of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These two space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
How many people do we need to create a new civilization? And not on Earth, but on Mars, and in limited conditions. And if we create this colony and send them off, what problems will they face? How can they survive that far away from home without any support? A recent scientific study sheds light on these questions, so let's take a look at it. Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the fourth most distant planet from the Sun and the seventh largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Celotti, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Celotti suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together.
Hey!
Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Celotti describes two things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do, make some tools for example, and all this must be produced in sufficient quantities before the literal deadlines. Celotti says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Celotti tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to two things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties, but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.